All right, well, thank you for joining us. We have the cold weather webinar that is sponsored by Tanis Aviation, and I know you guys are all really excited to hear more about flying airplanes and cold weather ops, and we're really glad that you're here. Just a couple of real quick housekeeping items. Everyone is muted except for the panelists. So if you have a question, and we certainly do welcome those questions, you can go ahead and enter those in the chat window at any time, and we'll be taking questions from the audience as we have time at the end of the webinar. So we're really glad that you joined us. Thank you for being here. First, before we start talking about airplanes and all those fun things, I'd like to introduce the person that is sponsoring this webinar, and also the person behind Tanis Aviation. And Doug, you got into Tanis last spring, but I know it's a very old company with a fantastic reputation, and you came into it and started doing some amazing things with technology, infrastructure, marketing. Everything is a lot of new stuff coming into this.
Yes, thanks, Paula. It is always a pleasure when you can take a company that has had many, many years, actually this is our 40th year, of great customer service and great products, and then just tap into technology that's out there to get our word out a little bit more. And we're happy to do that. We're using the social media, webinar, email blasts. I know several of you are, probably all of you are on our email distribution list. But since we're only a select number of people and sell product all over the world, we're going down this route to try to get our message out one-on-one to our customers, to our service centers, and really it's a pleasure to do this today.
Excellent. I know you're doing a lot with, you have a brand new website and some new STCs and all kinds of things as well, just in the last few months.
We have. We'll talk about that a little bit more in the end of our presentation about why we went into some of the supplemental type certificates and what we're doing to really touch base with a lot of our customers and getting word out. The aviation industry is a great network of people, but not necessarily always sharing good raw data and facts. And my background from mechanical engineering and calibration world is you build it on facts and do the test data, and then the test data can kind of prove out what you're doing. So it's a pleasure to be here, and I would love to introduce a couple of our panelists, if I should at this time, Paula.
Excellent.
Two of the folks that we've invited to be a spokesperson and panelists. One is Michael Wiskus. Michael is the pilot at Lucas Air Shows, also owner of West Metro Aviation, which is just outside of the Twin Cities here in Minneapolis-St. Paul. And Mike is started early in life as about a 10-year-old looking at the air show, and at the age of 17 got his pilot license, and now I think, Mike, I'm just looking, I think you have over 24,000 hours of flight time, does acrobatic air shows all over the United States, and probably most of all, recently can go on to the side of saying he's a cancer survivor too. So, Mike, if you just kind of give me a little bit of your background and what you're doing besides trying to get across the United States in a pitched airplane.
What I do is actually my passion. There's not a day that's gone by that I just don't love what I do. And I've had the ability to be able to fly a lot of different airplanes, go a lot of different places, experience a lot of different things. And hey, listen, a lot of people helped me through this. And but more importantly, I think I've probably made more mistakes than anybody else. So that helps on the learning curve to be able to pass a few things on to people. So I feel pretty lucky and blessed that after all those mistakes, I'm still here and we can go on and make good of some of this stuff.
Thanks, Mike. And then also along with us on the other side, from the south side of the United States to probably the furthest north side that we can get to, other than out on the frozen Arctic Circle. But Travis McCullough, who actually grew up, I believe, in the Carolinas, and is now the Director of Maintenance at Mission Aviation Repair Center in Soldotna, Alaska, down on the Kenai Peninsula. And for those that may or may not know, Pete Tanis, started with the Moody Bible Institute in the aviation there, and Travis has some roots in that side. I had the pleasure of seeing Travis's operation here this past May when there was an aviation gathering up in Anchorage. And I'd like to have Travis talk a little bit about what he does over there in Soldotna.
We are a ministry that works in the state, supporting missions in the state through flying missionaries around the state. We have 2 King Air 65-890s that we use to move the missionaries. We use them also to move supplies. We use them to move teams. But the other aspect of what we do is maintenance. We do a lot of maintenance on missionaries' airplanes. We have missionaries that have 206s, 185s, 172s throughout the state, and they bring them to us. And what we do is we do work on their aircraft. We do it at a very reduced rate. We give them parts at our cost, more or less, to make it so that they can maintain their airplanes as best as they can, and allows them to be able to do things that they normally wouldn't be able to do on the limited budget that they have. So we don't only work on missionaries' airplanes. We work on anybody that comes in the shop. So we have a very unique ministry in the fact of we take the commercial side of maintenance and use that to help support our ministry instead of like a lot of other ministries that use flying to supplement their work. So we get a wide variety. We go anywhere from our King Airs down to Super Cubs and work on pretty much everything in between. So we have a broad spectrum of aircraft we get to look at and have unique opportunities living in Alaska. The cold can do amazing things to aircraft at times. So it's been a learning curve, as you said. I grew up in Georgia, was born in South Carolina, then moving to Alaska and learning the uniqueness of cold weather flying and the effects it has on airplanes was a learning curve. And as you said before, I've made a lot of mistakes and have had to learn a lot coming up here. But it's been a very good thing to be able to see God do many great things through our ministry and be able to support those that are up here.
Thanks, Travis. And I think, Travis, you getting on almost your 10th year up in Alaska already, correct?
Yes, sir. Yes, sir. I've been up here 10 years.
So one thing Tanis has always done is done tremendous amount of time and research, and having people like Travis and other operators that we have that get onto the North Slope in various parts of Canada really do help us have a true proving ground of what we can do with our product. And then I'd like to introduce a couple people from our staff that are on the phone along with us. Dirk Ellis is our maintenance engineer and director of maintenance here at Tanis Aircraft Products. Dirk was actually one of the very first employees with Pete Tanis, and then has rejoined us again about 6-7 years ago after spending some time out in the various other parts of the United States. Dirk has many, many hours of flying cargo and commercial, and has seen the product that we produce come all the way from infancy to using technology to advance our product and put it into areas that we probably didn't even think about 20, 30 years ago. And along with Dirk, Lois Mara, who is one of our newest people to join Tanis Aircraft Products. She joined us on the marketing and sales side, and also is the person leading up this endeavor that you see here today, from the social media, webinar, email contacts. I know a lot of you are getting emails from me, but you probably already figured out that 95% of that's coming from Lois, and I'm just throwing my name on the bottom of it. But great staff here. We have a location in Blaine, Minnesota, where our engineering and admin sales is conducted, and then we have a manufacturing plant outstate Minnesota, about 120 miles west of here, where we produce our product.
Right. Did we want to hear a little bit from Dirk and Lois, maybe about their experience with Tanis?
Please.
I
Dirk,
guess I'll
if you want to start.
Please do, yeah.
I got involved with aviation as a structural component manufacturing out in Southern California, where I'm from, Santa Barbara. My dad was in the Air Force, air traffic controller, and moved out here, started working for Pete Tanis, and took a 10-year sabbatical and went and flew. Thought that would be a lot of fun, and ended up having an offer to come back to Tanis to do engineering, and so here I am back at it. Been able to introduce some of the things I learned out in the field into our product and also improve it.
And we have been putting on a presentation on the why, what, and how of preheat for a period of time. And what we thought, just to get the ball rolling here, is to go over some of the highlights and points that we've found by doing a lot of research, talking to our customers. And one of the things I hope that I can encourage during this webinar too is 90% of our great ideas are actually your great ideas. It's not stuff that we came up with. It's people like Mike and Travis and the people on the line here that say, hey, we really need this and we really need that. Okay. I'm going to actually toss it over to Dirk, and he's going to take the first couple slides here and go through some of our basics of why, what, and how to preheat.
Well, it's real simple. We like to heat, preheat. Probably the biggest thing is so the engine will start. One of the funny things that does happen when we try to start an engine under certain conditions, that we get a frosting of the plugs, which sounds kind of odd, but in fact it does happen, not even at freezing sometimes, just because moisture is created as part of the combustion process. So when we heat the cylinder head, those things are eliminated along with cylinder taper, which piston engines, at least the horizontally opposed type, not necessarily radials, have about a 2000 taper in them, and that is reduced. So we cut down a lot of the cylinder scoring and things like that happen, and we'll also blow by on the rings so that we introduce less pollutants into the oil and reduce the run-up time on the engine. So a lot of stress is reduced, right down to vibration for engine mounts and also exhaust. And the way we do that, where we heat is we heat multiple points on the engine. Again, the cylinder heads or cylinder assemblies is the main item that we want to preheat, and that heat does transfer into the case, but we also add heat to the case, and we put a little bit of heat on the oil. All we want to do is make the oil flow. Most people are using multi-viscosity oils now, so we don't want too much heat on it. And again, we just want it to flow so it gets up into the crankcase, and then is heated from the heating of the crankcase and the cylinder heads. So those are most of the reasons why we do it. It also increases safety. I've seen some engines that I pulled apart where I think main bearings have actually been spun hours before it actually showed up. So you may damage your engine in the winter on a cold start and not even have it show up for 10, 20 hours later, and it's here it is spring or summer, and you think, wow, I had a problem with my engine, and it's actually related to that cold start, that one cold start that took place. So those are some of the reasons why to preheat. We also have issues with torque oscillation, not so much here on piston aircraft, but more on turbine and especially on helicopters. And that's one of the issues they have with some of the designs right now with diesel engines that they're trying to put into helicopters. Just torque oscillation is very difficult to control, and it causes a lot of wear. We could talk a little bit on crankshaft clearance issues. And sounds kind of funny. Normally, when something gets cold, it shrinks away from its largest area of mass. But on crankshafts, it does shrink toward the crankshaft, just because we have so much mass outside of the on the rest of the case, as well as with the pistons. We have a tendency to shrink down on a cylinder right onto the wrist pin. And now we do machine those a little looser. We don't have the issues that we used to have as much, but that was a very common problem. Engine manufacturers, if you look in the surface information letters that we have available to us from both Continental and Lycoming, they recommend preheating at temperatures below 40 degrees. So if you think it's going to get down to 40 degrees or lower, then you should be preheating your engine prior to that time. And then we have in our operating manual, I usually recommend just going to those now. They're available on our website. and read through those. They're real simple to go through. We have a purpose and scope and then general information just in the very front page of that that give us good information on when to preheat. And we do reference and recommend that you follow the service information letters from the manufacturers, both Continental and Lycoming. And those two are available on our website as well.
Where we've got examples of the service information letter. This is SIL 03-1, which is from Continental. It's an excerpt right from there where they're talking about when and why and how to preheat. And then the next slide we'll talk about will be the actual bulletin, service instruction bulletin from Lycoming, 1505. And there they even go and state, that it must have preheat done at a certain temperature, and that the use of a heated dipstick is not approved because the heat isn't distributed throughout the engine.
Yeah, one of the ones I wanted to cover, we get a lot of questions about, is the service information letter from Lycoming, the SIL 03-1. They describe engine preheating using a engine-mounted preheat system in Section C. We actually helped them write that. So we've been in touch with Continental now for a number of years, and they've been using our system and are quite aware of it. And there is a section in there that describes our system. It says in Section C there, engine head heater, they call it thermocouples. They need a engine mount or a cylinder mounted heater, as well as a sump heater and crankcase heater. One of the questions that comes up here is people say, right in it, it says to only operate it for 24 hours or less, but it also says to follow specific instructions provided by the manufacturers for the preheat system operation. So that's one of the reasons why we have a very clear operating guide for not only our piston, but our turbine and helicopter systems as well.
Or depicting the differences between just the general preheat, which is a matter of just throwing heat on an engine, versus a multi-point preheat, and how we do it differently than some other folks.
Yeah, our system is a multi-point system, and just like everything in aviation, we want redundancy. So if we do have an element go out on a piston system, there's not that much of a problem. You can continue to use the system. We don't recommend that on our helicopter systems just because we have elements, all the way from the tail rotor to the main rotor gearbox, and we don't want a chance of scoring any bearings or anything like that with a cold start where you don't know that portion of it is out. But so far as a piston system, a lot of radiant heat just because it's under an engine cowl. Normally, if it's real cold, we're using a blanket included. We get radiant heat that heats the whole engine. So everything bolted to the engine on the accessory case is also heated up. Magnetos, vacuum pumps, things like that. It also reduces wear just having that heated. So that's the main reason we use a multi-point, and also to distribute the heat around. If we have a single point heating system, we'd have to put so much heat in one localized area. I've pulled engines apart where I don't even want to go into the nightmares of burnt oil in the backside of pads that are over wattaged, right down to cracks and sumps and holes bored through them with electrical problems where systems are poorly designed. So that's one of the reasons we've gone ahead and taken our product to the next level of certification with the STC, for example, which allows us to have it looked at by the FAA a little closer and gives us an airworthy product that has better traceability as well. And I think
one of the things to add to that, Dirk, through all of the testing that we've done, we've determined from a piston engine, it's really important for us to heat that cylinder head up first, or at the same amount of time with more wattage than other areas, because we deal with moisture, and we'll talk about that a little bit later. Moisture can vaporize from the oil, and we want to make sure that all the parts of that engine are above dew point. So if any moisture that's already inside the engine is going to become moving around, that it does not have a place to condense on, and the only way it condenses if it's below dew point. That's why it's critical to go ahead and heat that cylinder head first. And then I think on the next slide, Paula, you'll see that we actually did some thermo imaging on that,
Yeah,
where
in fact, we didn't do the thermal imaging.
That's true. Yeah, so it's actually a tech school institute, and you can talk a little bit about that, Dirk.
Yeah, and this is a real good example. I'm glad this slide is in here. One of the reasons why we do heat the cylinder head, of course, if you heat just at the base of the cylinders, like shown on this picture on the right side, what happens there is you don't get heat into the cylinder head, just strictly because you've got a huge mass of the piston, which blocks a lot of the heat transferring up into the cylinder head. And we want those rocker covers to be able to be lubricated right away, so we don't have a lack of oil. Some of the testing I did with Pete here a number of years ago when we were designing the system took 15 minutes or longer to get oil up into the top of the cylinders. So all that, the valve train on the top of the cylinder was getting wear just because it was not getting lubrication. We also did some testing with those bands before our competitor here started using them. I did testing of my own Bonanza at the time. In fact, I cut the test short because the cylinder base temperature has exceeded what was called out in the type certificate data sheet. There is a temperature called out. Now, Continental does spray oil, just like Lycoming does on the base of the cylinders, which does cut down on a lot of the temperature increases there. So we don't see those issues as much, but just was not a good place and conducive to our methodology of heating the engine thoroughly. When we put some heat on the case and then we've got in the cylinder heads, everything gets heated much more evenly and more efficiently. And again, like Doug was talking about, we don't have that transition area or a chance of a transition area from heat being on the crankcase and out to the cylinder heads. And that transition area would be in the worst place possible, and that's in the cylinders on the cast iron cylinder heads, where you'll end up getting pitting and rusting due to corrosion if you do have a dew point. If you do have dew point, have moisture collect in that area. So this is a real good example of that thorough heating that our system gives you.
Right.
And one of the things we do talk about in our operating guide is we don't tell you how to use the covers and things like that, but we do recommend getting a cover. And what our system does is it's designed to get the temperature of the engine to 60 degrees Fahrenheit above ambient temperature. So if it's 0, it gets up to 60 roughly above ambient. And if you have an engine cover over a cowl, of course, the engine is going to be heated more thoroughly and more evenly. And that whole environment that the engine is sitting in is then controlled. And our systems are designed with a number of things taken into consideration. And one of them is that we keep the wattage down so that it's doesn't cost as much to operate, and so the systems can be operated with a small generator, as shown in the picture there on the right. That happens to be the Polar Pumpkin, which flew up to the North Pole. And that individual that owns that aircraft's been all over and clear down to the South Pole with it as well. And he has our system on it, and he operates it, as you can see here, with a small generator. In fact, he's built a little tent for his generator now that goes right underneath the engine. And then we also offer wing and tail covers and even fuselage covers. Some of the regional airlines use our systems all the way from the preheat system to covers, wings, on all the appendages.
And then I'd like to jump in to just a little bit more about Tanis, and then of course you've heard us talking, and I'll turn it over to the people that we have as panelists, because I would hope that everybody on the webinar would probably think that Tanis is going to speak strongly about our product, but we are passionate about it, and we do it. We have been in business for actually selling our product for 40 years commercially, and we are the only manufacturer that has our product as part of the type certificate of airframe manufacturers like Cirrus, Cessna, Diamond, Pilatus. We even did a test with Bombardier this past February up in Siberia with Russian Federation on a cold weather soak at minus 48 degrees C temperature. And we've worked now with Viking, which is the owner of the Dash 6 in the Beaver product that they're now producing. And Dirk talked a little bit before about the STCs. When I came on board, we actually started the first STC on a helicopter system in the Bell 429, driven by the customer outside the United States. and we STC'd that. Then we went to the 4-cylinder Lycoming Continental engines, the Augusta Westland 119, and now the 6-cylinder Lycoming Continental and Franklin engines. We have STC'd, and we did that not because you need an STC. In fact, it's a minor mod here in the United States, but our product, 30% of our product is sold outside of the United States, and we were finding it a necessary object to do. And I encouraged our staff and our engineers to go through that next step of FAA certification to get another outside entity to look at all of our documentation, all of our data, to answer questions that were being asked, and we had to be able to prove some of the answers. And we do also have not only our engine preheat, but we do battery systems available for turbine and rotorcraft. As Dirk mentioned, I know we have a couple folks on the line on the webinar that handle more than just fixed wing product. We would answer some of these right away and then turn it over. Our system is designed to get its maximum effect in 4 to 6 hours. And that being, we will get, as Dirk stated, 60 degrees above ambient between 4 to 6 hours of plugging it in. And how hot does the engine get using Tanis preheat? That's 60 degrees above ambient. Some people say, well, what happens if I plug it in all the time? You can leave your Tanis preheat system plugged in all the time, because after we overcome that 50 to 60 degrees above ambient, then the amount of heat that we're putting in is also leaving the engine. So you can leave it plugged in. The question that gets connected right directly to that is, well, what about some of the service information that says do not plug it in for more than 24 hours, and won't I get corrosion? The manufacturers had to address all preheat systems, and usually that is centered in where there's only heat on the sump and possibly too much heat, where the oil temp is getting to 160, 170 degrees, and the moisture is vaporizing and then collecting again on a cooler part of the engine that doesn't have heat. That's the low dew point. And of course, once you're condensing on a part that doesn't have oil on it, it could lead to corrosion. But we've done multiple tests, and we test it every year. Our system can be plugged in. Now, granted, if you're not going to fly it at all, then we talk about preserving it. And is an STC required? Not in the United States. It's a minor modification, so that is not an absolute requirement. We, of course, are pushing that route now because that's allowed us to take our product that's available here all over the world, and it does give that extra level of confidence to either your customer or the end users. And how long does it take to install a Tanis preheat system? You know, that's always the catch, the tough one, and I'll probably let Travis talk more to that. It depends. You know, is the cowling already off? Are we on a single engine plane? And what other things are you doing at the same time? But we'll address that question from people that actually do it more, like West Metro Aviation and Mark.
Excellent. So we've got some questions for the panelists. So if you guys muted yourself, if you could unmute now, and we can go with either Mike or Travis first, whichever one of you guys is ready, willing, and able. But yeah, we'd like to have you talk more about what types of aircraft do you fly and work on, and you guys have very widely different experiences, of course.
Well, this is Mike, and West Metro, we work on everything from Cubs to Caravans. A lot of piston, some turbine, and I'll probably let Travis talk more about the turbine side of it. Sounds like he operates a couple King Air 200s up there, but I look at it from the standpoint of an owner. Simply put, guys, these engines cost a lot of money, and I know, you from 15,000 for an overhaul up to we just took in a Malibu Mirage that had to we put a new engine on it, and he did want to go with a factory new. Well, a factory new engine for a Malibu Mirage comes in a crate to your door at $100,000. That's crazy, but still, that's what it costs. So you start looking at these expenses, and what you're actually doing to your engine, I've gotten to the point where it comes to this Tanis equipment is actually just additional equipment for my aircraft. It is going to help me alleviate any damage that's going to happen to this airplane during cold starts or even normal starts. You'll end up seeing, even on a 40 or a 50 or a 60 degree day, I have a Pitts S2C and a Pitts S111B that I use for air shows. I don't want to take off until my oil temperature is at least 100 degrees. In fact, I prefer 120. And keep in mind that the difference between your cruise or your power settings, when you finally get to altitude and you're cruising, you're going to be between 180 degrees to 200 degrees on your oil temperature. So we all know that we don't want to supercool an engine. It's the same way the other way. We don't want to superheat the engine either quickly. We want to take it gradual. And that's the one thing that I love about Tanis is it does take 4 to 6 hours to bring it up to speed. It's a gradual speed to bring it up to that 60 degrees or to the temperature that equipment keeps your aircraft at. And then it gives it just that smaller amount of the distance between the 60 and the 100 degrees before you take off. On a cold day, you could sit on the end of the runway for a half hour waiting for it to come up to 100 degrees if you don't preheat this airplane. And none of us wait. I mean, come on, we're type A personality. If we don't like it, we'll just point it down the runway and pour the cops to it and blast off. Whereas if we've got that ability to be able to use that additional equipment that gets us up to the temperatures quicker, a little less time, that's why we fly, right? A little less time getting to where we want to go to. That equipment makes it happen, makes it easier for us. We've all been in the position where we've had the frosted plugs and the engine's backfiring, and you're trying to keep it running, and it's fighting you, and that's not just hard on the crankshaft. That's not just hard on the pistons. It's hard on everything. Every time that engine backfires, the airplane's not warmed up. It's not ready to run, and it creates more damage on the exhaust system. It's bad on every part of that engine. So I always look at it in terms of why don't you have a Tanis on there? It doesn't make sense. If you're looking at a $25,000 to a $50,000 engine and you've got a piece of equipment that will take care of it, and when you end up overhauling that engine down the road at 2,000 hours, if it's a TBO, the Tanis does come off and it does go back on the next engine that you've got. So it is, to me, like I said, just an additional component for my airplane. It's I don't think I could really operate with it, my equipment properly without it. So it's pretty important. I will say this too: we run 3 chieftains, the Lycoming IO 540s, the 350 horse turbocharged engines. We're moving people all the time from the Minneapolis area to North Dakota, and we'll end up leaving 2 of those chieftains up there on the ramps at these little airports and just fly one airplane back, so we're not deadheading all the equipment, trying to keep the costs down for these companies. When we get out there, we have our other aircraft plugged in and ready to go. And I can't tell you how many times you're looking at 15 to 20 below zero, loading guys up, hoping the airplane's going to start. This is all a cost factor also, because you've got, 8 employees getting on an airplane. If you don't start, it's not just the cost of trying to get the airplane in the hangar and taking care of the engine. You're also looking at employees and their downtime that costs the company. So to be able to convince companies to make sure that we do have the Tanis equipment in these aircraft, it's hands down. They say, do it, get it, take care of those airplanes, and take care of those employees. The only other thing I want to say about Tanis is, how simple is this? I mean, really. We have it set up in our chieftains, and actually in my Pitts S2C is the same way, to where there's a plug on the airplane. You don't have to go through the oil access door. You don't have to. You can actually, the way they've got it now is you've got these little plugs that are built into where the side of the fuselage. That all you have to do is plug the airplane in and not try to fish around and find it inside the oil access door. In fact, my Bonanza, I had a beautiful V35S, and Dirk, you gotta kick me in the head. Why did I sell that airplane? I loved that airplane. But Dirk was over, and we were looking at this plane, and we're going, well, where can we put this thing? Where can we put this plug in? And when it was sitting on the ground, I said, well, let's put it up in the nose gear area. It was a perfect access. The extension cord went up into the nose gear, it plugged in, and then when you're flying cross country, the nose gear is closed, the doors are closed, and there's no additional drag. So it's so versatile. I can't even begin to tell you how versatile and how easy it is just to use this equipment. But more than that, doggone, it just saves you money, and it saves that engine. And I don't know about you guys, but $25,000 engine, that's a lot of money to me. I just assume try to make that thing go to TBO as long as I can.
Right. And Travis, I know you have some probably amazing stories as well of airplanes that you've worked on with different issues and in your practice.
It's interesting being up here because we are a baby Navajo. We don't own the Chieftain, and we actually base it in Fairbanks. We don't have it tenured, and it sits outside plugged in all the time, just like you said, so we can take off with it. And if you know anything about Fairbanks, in the summer they can get up above 100 degrees, and in the winter it's not uncommon for them to get to 80 below. Of course, we don't fly at 80 below. Our max is 50 below. But we've had our pilots go out there, like you said, load up with our customers, get in the airplane, and start at negative 40. But you cannot start a Navajo at negative 40 without having the engines heated. Because if you do, like you said, you frost those plugs immediately, and if you don't get it, usually the first try, it will not start. But our pilots routinely not only start our Navajo at 40 below, we also start our King Airs at 40 below. And we travel into the remote parts of Alaska. So we're going to places where there are no plug-ins at times. We do take a generator even for a King Air, and we can plug it in and have it so the engines are heated and start them at negative 40. I have customers that are in these villages as well, and most of them actually use generators to work with the Tanis. And so we've had guys call us in asking us to troubleshoot the Tanis and saying they're having problems with it, and I start off always with the extension cord of the generator because generally it's not the Tanis. As a matter of fact, as of yet, I haven't yet have a problem with Tanis product itself not working out in the field. And with the new connections and the way they've done the SPC now, it makes it extremely easy to troubleshoot and to install. So the way that we work in our shop is with our customers. We had one of our customers come in one time and ask us to do a unique install with the Tanis because he stored his aircraft in a hangar, but he wanted to keep it warm, but he also needed to keep his battery charged because of the type of aircraft. It was a Cherokee 6. And some of the accessories he had on it, he wanted to make sure the battery is completely charged. So he asked me to put in an extra port for charging the battery because he got tired of opening his front baggage door and putting in an extension cord. So we started with that and actually tied the battery charger in with the Tanis. And then from then on, I had other customers who always put cabin heaters in. So I worked with Dirk, and we actually tried to come up with a single point use to be able to run the Tanis, charge the battery so it stays warm because at negative 40, it will still discharge, and then have it so that there's a plug inside the cabin. So now we have it and worked with Tanis, and they've developed and made a wiring diagram to be able to show how to use with the SDC a single point Tanis system that also charges the battery and has it so that you can run a heater inside the cabin. And we also installed a switch so that if it's in the summer and you don't want to run the Tanis, but you wanted to continue to run your battery charger because you may not fly your airplane a lot, you can flip the switch and it'll only run the battery charger. So Tanis does work well with their customers as far as making sure that whatever you need, that they will help you develop and help you work with. And a lot of the times with being in the villages and working and going, it's not a matter of we can wait because up in Alaska, the weather system can actually change. A lot of people see Alaska being in the bottom portion of a map, and they don't understand if you're to overlay Alaska on top of the United States, it goes all the way from Savannah, Georgia, all the way over to California. It's a huge state, and when we travel long distances. We go over mountains, basically swamp areas that you wouldn't think would be in Alaska that are here. and there is no place to land. So to have an engine that could possibly fail because it was not heated, not an option, just because of the environment we're in. So a lot of our aircraft, and trying to make sure that they work all the time, every time, so that our pilots don't have to worry about them, we use a Tanis on it. And with the missionaries and even with the commercial customers we have coming the door, they question, and I say the same thing. It's one of those options. You don't ask, should I have this on my airplane? It's, why don't you have this on your airplane? Because of the environment that we live and work in, it can destroy an engine. I can't tell you how many times I've taken cylinders off to do an engine inspection because we found metal, and sure enough, the whole engine on the inside is just destroyed, either because of a spun bearing or because of metal being deposited from the camshaft whenever it was doing cold starts most of its life. So a lot of my customers, I encourage them to purchase the system and put it in. As far as taking and installing the system, it depends on what the customer wants. And as Mike was saying, with their plug layout, we can put a plug almost anywhere. And they just came out, Tanis did, with an LED light that makes it so whenever you put that LED light, you can see it from a long ways away. So a lot of my customers who have it plugged in, the aircraft is basically more than across the field. They can still see the light from that and make sure that it's still on. And so with us working with all these different aircraft, twin, singles, installing these systems, it depends more on the customer and where they want it as to how long it takes for us to do it. So to give you a flat answer and say it only takes a couple hours to install it is not necessarily the best thing to say, because it really depends on what you want in your airplane, where you want it, and how you want it done. And that's the great thing about the system, is it's very, very versatile. You can put the interior plug in many locations. You can put the battery charger wherever you need to, and actually the installation of the Tanis system on the engine and then wiring it to the plug somewhere else on the airplane is all very easy and be able to put anywhere. So it really depends on the customer and what they want. Mike probably works the same way. It's whatever the customer wants, and we work to our best to suit them and their desires, but also give them quality products. We do have the band products up here, or other different competitors up here, and doing our own little test, which is nothing compared to what Tanis does. You could see a huge difference whenever you plug them in. Whether it be that you can tell that the sump is overheating, or whether it be that you could tell that the cylinders aren't getting fully heated. We've seen the same thing here in Alaska, because it's easy for us to push the airplane outside and be negative 20 and do a quick check if we need to, because things can get cold pretty quick when it's negative 20 outside.
So you have a lab just outside your hangar.
Well, it was interesting when we first moved here, being from the south. Just the temperature and the cold. I had some friends come over, and they said, "Hey, do you have room in your freezer?" We're like, "Well, actually, we don't." And they said, "Okay, we'll leave the ice cream outside. It'll get a little bit harder, but it'll be okay." Because it's negative 20. Never thought of it before.
Great. Well, you did such a good job answering that question. I'm going to skip the next one. And, we talked a little bit about geography and conditions. So, and I know you kind of started with this. And so we'll just maybe let you continue, Travis, and then we'll move back to you, Mike. Why not use other preheat methods? And Travis, I know you started answering this one, so you're way ahead of me.
Well, with us having other people come in, and usually whenever you have a product, you're passionate about it. And you want to. So I've had other customers come in and they're like, "Well, I don't need a Tanis because I have this system." I'm like, "Well, I understand. Mind if I take it outside and compare it to ours and see the difference?" And sometimes they come back and we show it to them, and we will strip the cowlings off, push the engines outside, and heat them up, and because it will give you a much better showing, kind of like your image of your thermal imaging before. And it's amazing to see the difference between the two. And if that was the only thing, that would be the only thing that was needed. But if you add the versatility and the ability to be able to combine systems and be able to make it so that you're not having to crawl in your engine cowl, especially up here, because whenever we have customers that use the Tanis, we always have them use an engine cover. We always take and cover the wings. Because it's not uncommon for us to go out to our airplane and there'll be 6 to 10 inches of snow on top of the airplane. We have to brush it all off. We have to take all the covers off. If not, it's been that half icing, half snow, and the covers could be frozen on if you're not careful, if you have the wrong type of covers. And so whenever you have those covers on and you have all that on and you're using an improper system, it just doesn't heat the same that a Tanis does. So having the covers on the wings and on the engine and keeping that heat in there, there is a big difference. And you're doing, like you said earlier, a thorough heating of the system. Because up here we have customers that come up and don't use the Tanis, and the reason is because they don't stay here in the winter. And the other thing we do is pickle their engine. We do a couple airplanes a year of pickling. We call them snowbirds. They come up here for the summer, then leave in the winter. And they'll just hand me their keys, walk away, and we'll pickle their engines and then do an annual and have the airplane for them when they come back. And you can have some of those customers do that. We have the others that don't, and you get to see the corrosion and the problems within the crankcase because of that.
Wow. Mike, how about you? Have you tried the other preheat methods, and what's your comparison?
Man, we've tried it all. The thing I like about the Tanis is it is a complete system. I mean, it's complete. You get everything that needs to be warmed up on all the entire aircraft. I mean, you talk about the oil, you talk about the cylinders, the case itself. I remember, when I first started flying, we'd be trying to preheat the Cessna 150 or the 152 out there, and we bring up the preheater and stick those hoses in the nose, and you'd be bubbling the cowls, and the only thing that you were really heating was the cylinders and the plugs, which allowed the airplane to start. But unfortunately, the oil was still, very thick and wasn't moving, and so for the first, minute to 3 minutes, you're begging for that oil pressure to come up because that oil's trying to pump its way through, but it's just not getting to the parts that it needs to get to. And of course, there you go. You're creating more metal in the engine. You're beating the parts up, and that just is not good. Besides that, you end up having to down the road repair the cowling from overheating, and you can't regulate the temperature the right way. As for some of the competition and the other guys, we've tried them too. And tearing an engine down or actually pulling the cowling off, you'll even see some of the guys that have gone down to some of the auto parts store, grabbed some of the automotive products, stuck them with silicone on the bottom of the pan, and hope that works too. But of course, you don't know what temperature that gets to, and if it gets too hot, it does weaken that pan and that aluminum under there, or the steel. And it could also, like Dirk said earlier, you pull that pan off, you see baked oil on the bottom of it. Like I said, the nice thing about the Tanis side of it, it's complete. It takes care of everything. It heats everything from the oil to the cylinders to the case itself. So there's nothing that's warmer or colder. It's all even through the entire system, and it makes a big difference. Again, don't be fooled by just trying to heat up the cylinders, because sure, that will prevent the plugs from frosting. And of course, if you try to start your airplane when it's cold and it's not firing completely, and you throw a heat on the cylinders, you will get it started. But that oil is not warm, and that is so critical to saving the life of that engine. You do that a few times, that engine is not going to make TBO. It's just not going to. And I will say this: we actually had one Chieftain 358 Charlie. We just spent. It came back from Bulldog engines. We had a crack in the case, and that engine didn't start out with the Tanis heater on it at all. We ended up picking it up in Memphis, Tennessee, as a backup to our equipment for the company that I fly for, and we ended up having a crack in the case, and that was the first few weeks of operation on that. And I honestly believe it has to do with operation. There was 1,300 or 1,200 hours on that engine, and who knows how that engine was operated prior. The other Chieftains that we have, we do have the Tanis on, and we have a ritual of using it all the time. It's the first time I've seen a crack on that, and it was up in the front on the right side, just forward of the number one cylinder, and it was a pretty good crack. And luckily, we got it welded. We didn't have to replace the case, but we found it by a small oil leak, and we started working with the through bolts a little bit, checking to see if the case just needed to be tightened up. Every one of the two bolts for that case, they were loose. And what that tells me is that engine case had expanded and contracted and expanded and contracted all of these years without the proper equipment on board, like I said, Tanis, to make sure that it doesn't make those drastic heat changes, from, 10 degrees to 100 or 120 before takeoff in a 7-minute, 10-minute time. It wears on those engines. And that was a $15,000 to $18,000. It might have even been a little bit more than that, just to fix the case, put the engine back together, and keep going. That wasn't even an overhaul. So it's a complete system. Tanis is totally complete, and that's what I like about it.
Excellent. Great. And then we've got just a few more minutes, so I'm going to go to the next question, and that would be, what are your thresholds? When should you? What are your warning signals that this is when my Tanis should be on, and when I need to start thinking about it? And if you guys could take maybe 2 minutes each on this one.
Go ahead, Travis.
I can always say that here in Alaska we have multiple seasons, but our winter season lasts pretty long. So generally about this time of year up until May is whenever we will run a Tanis pretty much the rest of the year, just because of the temperatures. We're always low enough that there is no question. And even sometimes into June, we will still be using the Tanis because of the temperature. So for here, it's a temperature related thing and seasonal, just because of how long we are in a cold weather area.
And for my operation, this is Mike again. We usually use it right up. Of course, we're in Minnesota. We'll end up using it right up to June, and then again after August and September. And what we look at is not just because of the frigid cold. It's the time to get the engine run up to the point to where we can get our takeoff temperature and go. How much time do we have? How long do we want those drillers that we're taking up to North Dakota to sit on that airplane to wait for that temperature to come up? It decreases the amount of time it takes to bring it up to the proper temperature for takeoff. So we maybe use it a little longer through the season than a lot of people, but it's just paid off for us, both taking care of the equipment and less time on the ground. The idea is to get in the air and get going, and that's why we run it a little later in the season and a little earlier in the season.
Excellent. Well, you guys have very different scenarios for practicing that, and I wanted to give a little bit of time back to Doug.
Thanks, Travis and Mike. We obviously asked them because they are the people that we really sell to, and that's our service centers and our FBOs. And I know we have a mix of people on the webinar. Actually, I had two questions. One always comes up is the wattage. Our 4-cylinder system on a piston is 240 watts, 6-cylinder 460 watts. So the little Honda 1000 generator you saw in one of the previous pictures can actually run for about 6 or 8 hours and provide the preheat if you don't have ground power. And there was a question about an AS or Airbus helicopter. And John, we'll take that one offline. We have not heard that before, so I would, if you can email us your contact info, I think we probably have that here. We'd like to gather some more information regarding some hydraulic oil and moisture issues that will drive in a little bit further. But Paula did echo our website just got launched, a new website. It just got launched here about a month ago. And what we're trying to do is to put all of our data, documents, and more pictures as we keep on taking them of our product onto the website so that our audience that is now global has a means to being able to gather that information, take a look at what's available, or more importantly, download installation documents, flight manual supplements, pilot guides, things like that. And also I stated earlier in the presentation, we'd love to hear from you. We get most of our product changes and good ideas from our customers. And if you have something that you have as a question, we are always here. Technical folks, sales folks, we're not a one-person, two-person operation. We're here to answer your question, and we also like excuses to go out and find real life test beds like Travis's in Alaska. Now, I will say I prefer to visit Travis in May, June, July, not December, January, February, but I think they only have about 4 hours of sunlight during that period of time. But I appreciate your time. We'd love to hear from you. We would also like to get the response back from this webinar and our website if you have suggestions. I know a couple of them came in before of doing them at different times because in the middle of the day, evenings, or some other time when pilots can get a hold of them, and we'll sure take that into consideration and move forward from there. But otherwise, I'd like to thank the panelists and also John and Paula for doing the housekeeping on the backside of the webinar. Appreciate your time.
Excellent. And yeah, we'd also like to thank you guys. You make our job a whole lot of fun. We get to talk to the coolest people on the planet, and we learn a lot from these. And then I think a lot of the people who are in the webinar are getting Tanis's cold weather ops safety tips in email, in your email box, and those come out every Tuesday. If you're not getting those, or if you know someone who should be getting them, you can go to aircraftpreheat.com, which is just a landing page for those cold weather ops safety tips. Tanis's website is what it always has been, which is tanisaircraft.com. And of course, that's where another great place to get good information.